A list of 9 real numbers consists of 1, 2.2, 3.2, 5.2, 6.2, and 7, as well as x, y, and z, with x less than or equal to y less than or equal to z. The range of the list is 7, and the mean and median are both positive integers. How many ordered triples x, y, z are possible? So what makes this problem tricky is that we don't know where x, y, and z are relative to these 6 numbers. So let's first write out the 6 numbers in a row. So the sum of these 6 numbers is 24.8. And in order for the mean to be a positive integer, the sum of the 9 numbers has to be a multiple of 9. This is going to imply that x plus y plus z has to be 2.2 more than a multiple of 9. So we're going to abuse a little bit of modular arithmetic notation and just say x plus y plus z is 2.2 modulo 9. This means that x plus y plus z, it can equal any of the numbers 2.2, 11.2, 20.2, etc., as well as negative 6.8, negative 15.8, and so on. Okay, so we've taken care of the mean condition. Now let's look at the median. So we know that the median is a positive integer, but if we look at these 6 numbers, the middle number, there's no integer within them. This means that the median is most likely going to have to be x, y, or z. So because we have 9 numbers, the median is going to be the 5th number in the list when we sort them. So we can see that the smallest possible median we can possibly get is 3. This happens if I place 3 here and 2 more numbers to the left of this 3. This will force the median to be 3. And it is also possible that the median is 6. And 6 is the largest possible median I can get. But it's also possible that the median can be 4 or 5 if the middle number is between 3.2 and 5.2. So there are going to be a few different cases. So we'll start with our first case. The first case is if the median is 3. The second case is if the median is 6. And the third case, we'll group these as a separate case where the median is 4 or 5. So let's take a look first where 3 is the median. However, we also know that the range of the list is 7. Because 7 is the largest number and the remaining 2 integers have to be less than 3, we can actually conclude that the smallest number has to be 0. And then the third number we should be able to figure out. Now let's remember that x plus y plus z can be 2.2, 11.2, negative 6.8, etc. But we actually see here that there's no possible value for the third number, because if x plus y plus z is 2.2, this is going to force the third number to be negative 0.8. But the problem is that negative 0.8 cannot be one of the numbers because then the range of the list is no longer 7. So we can check that 3 is not possible as a median because that forces at least one of the other conditions to be violated. So case 1 cannot happen. Now let's look at case 2. Case 2 is where the median is 6. Now, if the median is 6, that means that the other two numbers are going to be something larger than 6, but we don't know exactly what they are. And using similar reasoning as before, we can conclude that the largest of the three unknown numbers has to be 8, because the range is 7. Now, if we look again at the sum of x plus y plus z, we see that 20.2 is very likely. It turns out that this will be the sum. This is going to imply that the remaining number will be 6.2. So this gives one and only one possible triple xyz, which is 6, 6.2, and 8. Lastly, if the median is 4 or 5, this gets a little bit trickier just because there are more cases to deal with. So if the median is 4 or 5, then again, we're going to use the fact that the range is 7. Now, the only problem though is that we don't know if the smallest number is 0 or if the largest number is 8. And there's even one more case, which is very easy to miss, is that the smallest and the largest numbers could be the range, meaning that the smallest number could be x and the largest number could be x plus 7. So we'll need to address these three cases separately. So if the smallest number is 0 and the median is 4 or 5, this is going to force z to be greater than the median. And with a little bit of trial and error, we see that there is one possibility, namely 0, 5, and 6.2. Because remember that x plus y plus z has to be 2.2 more than a multiple of 9. I'll leave it to you to check that there is no triple where the median is 4 and x is 0. On the other hand, if the largest of the three unknowns is 8, then it's not too hard to check that there are no ordered triples that satisfy all of these conditions. Because again, we can look at the sum of the three unknown numbers and conclude that no matter what the third number is, and no matter what the median is, there's going to be one of these conditions will be violated. And then lastly, if the smallest number is x and the largest number z is x plus 7, then we can solve the equation 2x plus 7 plus 4 or 5. This has to be 2.2 more than a multiple of 9. We also need to keep in mind that for this case, we specifically require that x is between 0 and 1, so that x has to be less than 1, x plus 7 has to be at least 7. So we can see here that the only possibility to consider is that the sum of x and x plus 7 and 4 or 5, it's going to have to equal 11.2. So there's a little bit of trial and error that we can do here, but the idea is that if the smallest number is x, the largest is x plus 7, and the median is 4 or 5, we're going to have two different equations, and then we can solve for x in each of them. Now, it turns out the only possible way that this gives us a valid solution is if the median is 4, and the sum of the three unknowns is 11.2. This is going to give us x equals 0.1, and this is going to give us the ordered triple 0.1, 4, and 7.1. So altogether, we counted 1, 2, and 3 ordered triples x, y, z. Therefore, our answer is going to be 3, which is choice C.